Access control list. In computer security, an access control list ACL is a list of permissions associated with a system resource object. An ACL specifies which users or system processes are granted access to objects, as well as what operations are allowed on given objects. Each entry in a typical ACL specifies a subject and an operation. For instance, if a file object has an ACL that contains Alice, read, write Bob, read, this would give Alice permission to read and write the file, and only give Bob permission to read it. Implementations. Many kinds of operating systems implement ACL or have a historical implementation. The first implementation of ACL was in the file system of Multics in 1965. Filesystem ACL. A filesystem ACL is a data structure, usually a table containing entries that specify individual user or group rights to specific system objects such as programs, processes, or files. These entries are known as access control entries ACE in the Microsoft Windows NT, OpenVMS, and Unix-like operating systems such as Linux, Mac OS, and Solaris. Each accessible object contains an identifier to its ACL. The privileges or permissions determine specific access rights, such as whether a user can read from, write to, or execute an object. In some implementations, an ACE can control whether or not a user, or group of users, may alter the ACL on an object. One of the first operating systems to provide filesystem ACL was Multics. Primos featured ACL at least as early as 1984. In the 1990s, the ACL and RBAC models were extensively tested and used to administer file permissions. POSIX ACL. POSIX 10.03.1/10.03.2 Working Group made an effort to standardize ACL, resulting in what is now known as POSIX 1 ACL or simply POSIX ACL. The POSIX 1/POSIX 2 drafts were withdrawn in 1997 due to participants losing interest for funding the project and turning to more powerful alternatives such as NFSv4 ACL. As of December 2019, no live sources of the draft could be found on the Internet, but it can still be found in the Internet Archive. Most of the Unix and Unix-like operating systems, e.g. Linux, since 2.5.46 or November 2002, BSD or Solaris support POSIX 1 ACL, not necessarily Draft 17. ACL are usually stored in the extended attributes of a file on these systems. NFSv4 ACL. NFSv4 ACL are much more powerful than POSIX Draft ACL. Unlike Draft POSIX ACL, NFSv4 ACL are defined by an actually published standard as part of the network file system. NFSv4 ACL are supported by many Unix and Unix-like operating systems. Examples include AI. There are 2 experimental implementations of NFSv4 ACL for Linux, NFSv4 ACL support for X3 file system, and the more recent Rechackles, which brings NFSv4 ACL support for Extra file system. As with POSIX ACLs, NFSv4 ACL are usually stored as extended attributes on Unix-like systems. NFSv4 ACL are organized nearly identically to the Windows NT ACL used in NTFS. NFSv4.1 ACL are a superset of both NT ACL and POSIX Draft ACL. Samba supports saving the NT ACL of SMB shared files in many ways, one of which is as NFSv4 encoded ACL. Active Directory ACL. Microsoft's Active Directory service implements an LDAP server that store and disseminate configuration information about users and computers in a domain. Active Directory extends the LDAP specification by adding the same type of access control list mechanism as Windows NT uses for the NTFS file system. Windows 2000 then extended the syntax for access control entries such that they could not only grant or deny access to entire LDAP objects, but also to individual attributes within these objects. Networking ACL. On some types of proprietary computer hardware, in particular routers and switches, an access control list provides rules that are applied to port numbers or IP addresses that are available on a host or other layer 3, each with a list of hosts and / or networks permitted to use the service. Although it is additionally possible to configure access control lists based on network domain names, this is a questionable idea because individual TCP, UDP, and IP headers do not contain domain names. Consequently, the device enforcing the access control list must separately resolve names to numeric addresses. This presents an additional attack surface for an attacker who is seeking to compromise security of the system which the access control list is protecting. Both individual servers and routers can have network ACL. Access control lists can generally be configured to control both inbound and outbound traffic, and in this context they are similar to firewalls. Like firewalls, ACL could be subject to security regulations and standards such as PCI DSS. SQL implementations. ACL algorithms have been ported to SQL and to relational database systems. Many modern 2000s and 2010s SQL-based systems like enterprise resource planning and content management systems have used ACL models in their administration modules. Comparing with RBAC, the main alternative to the ACL model is the role-based access control RBAC model. A minimal RBAC model, RBACM, can be compared with an ACL mechanism, ACLG, where only groups are permitted as entries in the ACL. Barkley 1997 showed that RBACM and ACLG are equivalent. In modern SQL implementations, ACL also manage groups and inheritance in a hierarchy of groups. So modern ACL can express all that RBAC express and are notably powerful compared to old ACL in their ability to express access control policy in terms of the way in which administrators view organizations. For data interchange and for high-level comparisons, ACL data can be translated to XACL.